So Unit 3 of this class is on investment. And we are going to start tonight talking about simple interest. And our first step is to calculate the amount of simple interest. The amount of interest for simple interest is found using the formula. Interest, or the dollar amount of interest, is equal to the principal times the rate times the time. The principal is the amount of money you start with. The rate is just your percent as a decimal. And your time is always given in years. So let's say I ask you to find the simple interest on $4,000 invested at 6% for 3 years. The amount of simple interest is going to be I equals P, the principal in this problem would be the $4,000, good, times my rate, well, 6%, but we have to express it as a decimal, would be 0.06. And my time is 3 years. So just times 3. So we multiply those out, we are going to get what? $720? Perfect. So that's the simple interest on $4,000 for 3 years at 6%. Now, what we're going to apply this to, we're going to actually talk about 2 different types of loans over the next couple of weeks. Or notes, I should say, not loans. But we're going to talk about, the first one we're going to talk about is a simple interest-bearing note. So simple interest-bearing means it does bear interest. You add interest onto the balance to get a maturity value, which we'll go over in just a second. But simple interest means the interest is only calculated on one of 2 conditions. One, interest is calculated when there's an action on the note. An action would be a payment or a withdrawal. Or 2, at maturity. In other words, at the end of the note. I know it's not how you spell maturity. There's probably an A in there. There you go. It's been one of those days. So, otherwise, if you don't do anything with that note from the time you start it until the end, interest will not be calculated in at all until the very end, at maturity. So for a simple interest-bearing note, we start out with the principal. And we're going to add to that the interest, and that's going to give us the maturity value. The principal in a simple interest-bearing note is often also referred to as the face value of the note. Now you might think, well, that's pretty obvious. The face value is the amount you get, the starting amount of the note. But next week we're going to look at something called simple discount notes where that is not necessarily the case. We might even touch on them a little bit before we're done tonight. So let's say I want to find the maturity value. of a, it's the same numbers, $7,000 note invested at 3% for 5 years. So this is a two-step process. We do have to start out just like we did before, finding the interest. I is going to equal what? 7,000 is our principal, times 2% is 0.03, yep, and times 5 years. So that's going to be $1,050. Very good. That is our amount of interest. Now we're asked for the maturity value, so what do we have to do next? Perfect. 7,000 plus the 1,050. So $8,050 is the maturity value. Okay, so before we get too far into these notes, we want to look at some of the algebra we can do with them. So let's say we want to find the principal on a note that earned, excuse me, $480 interest at, that's blacked out, 3% for 2 years. So here we're going to set this up. It's still I equals PRT. In this case, though, I know I. I is how much? 480. The principal is what I'm looking for. My rate is 3%, so 0.03, times 2 years. So before I go to solve the equation, I have to combine whatever I can on either side. So I can do 0.03 times 2 is going to be 0.06. And now I can get P by itself by dividing by 0.06. 480 divided by 0.06 is 8,000. Make sense? Dollars. Okay. Let's say a 5-year note on $6,000 yields $1,500 in interest. Find the rate. So similar thing, we're going to set it up. I equals PRT. What do I know here? Well, do I know I? What is it? Careful. 1,500 is the interest. Do I know P? Yes, what is it? That's the 6,000. Do I know R? No, that is what I'm looking for. Do I know T? Yeah, 5. So once again, I combine what I can combine. The 1,500 is going to sit by itself, but I can do 5 times 6,000 is 30,000. Times R, then what? Divide by 30,000. Good. R equals 5.05. So 0.05 that comes out to be, which is 5%. Any questions? Let's have you try some. No, technically it's not. It's more appropriate to put it as a percent. But if I ask for the rate, I guess technically 0.05 is the rate. So yeah, it wouldn't be wrong. Find the principal if a note earns $560 in interest at 7% over 4 years. Try that one in your notes. So when we go to set this up, 560 is I. We're looking for the principal. The rate is 0.07, and our time, of course, is 4. So again, we combine what we can. 0.07 times 4 is 0.28. Then what? Divide by 0.28. Which gives us $2,000 is our principal. How many of you got that one? Good deal. Now let's try one more. How long does it take for $8,000 to grow to $9,600 at 4% interest? Now, if you try that one in your notes, I'll warn you, there is something here that's a little bit tricky. You're going to have to dig for a bit. We'll look at it in a couple of minutes. We said this one was a bit tricky. We'll see if you caught why. Interest equals PRT. How much is the interest? Perfect. 1,600. It grows from 8,000 to 9,600. The difference is the interest. Principal, 8,000. Rate, 0.04, so 4%. We are looking for the time. So we're going to do 8,000 times 0.04, which is what, 320? Then what? Divide by 320. And we get that our time is 5. Of course, time is always in years. So yes, that is 5 years. Any questions? Okay. Well, simple interest is not really practical over 5 years or even 2 years. Most banks do not like to do simple interest for that long of a period of time. So most of the time when we're looking at simple interest, we're looking at a shorter period of time. For the longer periods, you're going to use compound interest, which we're going to look at in a couple weeks. So let's take a look at, let's say you are going to invest $9,000 at 2% for 6 months. Want to find the maturity value. Well, step one is to find the interest. So the simple interest, I, equals the principal of 9,000 times a rate of 0.02. The trick here is the time. It's 6 months, and we said our time was always given in years. So to make 6 months into years, it's just 6 over 12. So 9,000, let's clear it out, times 0.02 times 6 over 12 is 90. There's $90 in interest. Are we done? No, I asked for maturity value. Take $90 in interest, add it to the $9,000 in principal, get $9,090 of maturity value. In your notes, let's say you borrow $1,800 at 7% for 3 months. How much will you pay back? I'll give you a couple minutes to try that. So our interest is going to equal our principal, which is $1,800, times our rate, 0.07. Our time will be 3 over 12. What's that give us for interest? What's that? $31.50? $31.50. So then we get a maturity value, 1,800 plus 31.50, so $1,831.50. Any questions? Okay, normally where the questions start. How much interest is earned on $5,000 invested at 3% for 120 days? Seems like a simple question. First part is simple. Principal, $5,000. Rate is 0.03 for the 3%. Here's the part that's tricky. You would think you're just going to put 120 over 365, right? It's 365 days in a year. But we need to know more information here. There are two types of interest figured out daily. There's ordinary and there's exact. Both ordinary and exact interest count the exact days. So what does that mean? That means if I'm going from starting on one date and ending on another date, they count the exact days that are in between there. They don't fudge the days between dates. But they do change what they consider to be a full year. There's the denominator of our time. Ordinary interest, we divide by 360 days. Exact interest, we divide by 365 days. Like I said, when we count our days, we're still figuring 365 days in a year. We're still counting all of them. It's only when we put them in the formula here to find the interest that we're changing it to 360 or 365. Why would we ever want to use 360 days in a year? Well, a lot of stuff we do dates back to the days before calculators. When a banker who had money deposited in his bank had to sit down and calculate the interest on those deposits by hand. Well, it is really a bear to try to figure out the interest if you're dividing by 365 days in a year. So they just accepted that they were going to divide by 360. Now, the other thing they did was just every month was considered to be 30 days. That's why they did 360. So every month was just 1/12 of a year. So that made their life a lot easier. Their calculations were a lot simpler doing it that way. Well, now that we have computers and calculators and all that stuff and we can calculate it exactly, why would we still do that? Well, because if the bank is loaning you money and they're figuring it out on they're still counting 365 days in the year, but only dividing by 360 in their formula, what does that do to the amount of interest they get? They get more interest. So it's to their benefit to keep doing that when you owe them money. Now, if they owe you money in a savings account, they're probably going to use exact interest because then they pay as little interest as possible on it. But we do have to know which is which. So let's start out, we're going to do this one both ways. Let's start out figuring out with ordinary interest. So this is going to be 120 over 360, which ends up being, what's that? $50 in interest. So the interest is $50. Let's do it again now with exact interest. So 5,000 times 0.03 times 120 over 365. That ends up being how much? What's that? $49.32? Perfect. So you can see there's 68 cents to the bank's advantage. If you owe them money on a loan, they're going to charge ordinary interest. You're going to pay $50. If they owe you money on an investment, they're only going to pay you exact interest, $49.32. So they save that 68 cents. Which one is more common, do you think? Yes, ordinary. In fact, in any problem, if it does not specify ordinary interest or exact interest, you will assume ordinary interest. So find the maturity value of $12,000 invested at 6% exact interest for 180 days. So you know, so I want you to try that one. So we're going to find our interest first on the principal of $12,000 rate of 0.06 times 180 over 365. It does say exact. What does that give us for interest? 350 what? 55 and 7? Okay. $355.07. So that's 12,000 plus 355.07, $12,355.07. Not so bad. Find the maturity value of $3,500 borrowed at 7% for 60 days. So again, let's try that one. So for this one, 3,500 times 0.07 is your rate. It is 60 over 360 because it does not say ordinary or exact, so we assume ordinary. So that gives us interest of $40.83. So the maturity value, I'm just going to do it right here, plus $40.83 is $3,540.83. What's that? This here? I'm just multiplying 3,500 times 0.07 times 60 divided by 360. Let's give me that. Yes?
Was the one before that, was it 355.07?
Yep.
Okay.
Yeah,
Thanks.
Does it matter when you say borrowed and invested?
the interest is calculated the same way. Yep.
And then for the value one, is it always going to be finding the principal? Or, I mean, the other way around, right?
Finding maturity value?
Yeah.
Yeah.
It's not going to be the other way around.
Finding the principal from it? Well, just like we did on those equations earlier, we are gonna look at a couple of those. Find the principal.
Because I kind of thought when you said borrowed and invested, maybe that changed it.
No, it doesn't unless, I mean, normally when you're investing, they're going to pay you exact interest. But if it doesn't say, you still assume ordinary. So let's look at find the principal on, find the principal if a 90-day 3% investment earns $150 interest. So 90-day, it does not say exact or ordinary, so we're going to assume ordinary. So this is going to be 150 as our interest. We're looking for the principal. Rate is 0.03, and our time is 90 over 360. This example doesn't work out too bad, but I do want to show you how to use the functions of your calculator on a problem like this so that we don't have problems with it. So we're going to have to combine everything on each side of the equation that we can combine. So the p is going to stay there, but we are going to take 0.03 times 90 divided by 360. So 0.03 times 90 divided by 360. Now here that gives us 0.0075, which is a manageable number. We could write it down and punch it back into our calculator if we wanted to. Many cases, though, many times it will not be that simple. So what I'm going to show you how to do here in our next step, we have to divide by that number. So our principal is going to be equal to the $150 divided by that 0.0075. Well, most of your calculators, pretty much all of your calculators have the functionality to do this. I'm going to put in my $150 and divide by, instead of typing in the 0.0075, I'm going to tell the calculator to use the previous answer. For most of you, that should be down by your equals key. Usually it's on your negative key. You have to hit the second or shift, and then that key. That tells the calculator to use the previous answer. So that gives us $20,000 here. Everybody find that key? I said you have the equals key down there. Most of you then have a negative key by it. Above the negative key, it should say ANS on many of your calculators. That's the FX, isn't it? That's the FX?
No, actually, I did a question.
Okay, yeah.
When I did the 0.3 times x divided by 7.5
Okay. -3, yeah. -3 or -03?
Yes.
That's scientific notation.
Okay.
What that is saying is 7.5 times 10 to the -3rd. What it is saying is the 3 is telling you to get the actual number, you got to move the decimal point 3 spots. The negative is telling you got to make it smaller by 3 spots. So you're going to go 1, 2, 3, filling in the zeros, so 0.0075. Okay. Any other questions? Anybody not find their answer key on their calculator? Okay. Oh, sure. Okay, so let's do another one similar to that. Let's say a 100-day loan earns it's a little more believable. It earns $62.50 in exact interest on a principal of, what do I put in here? $18,000. Find the interest rate. See if you can figure that one out in your notes. Okay, so we have $62.50 interest. We have $18,000 in principal. We are looking for the rate. Our time is going to be 100 over 365. Good. This is going to be one where we're definitely going to need to use that answer function on our calculator. So we're going to combine our 18,000 and our 100 over 365. 18,000 times 100 divided by 365. So we got 4,931.506, blah, blah, blah. Is it 91? No, that's right. Times R. Now, I'm writing that down just to have something in there, but I'm keeping it in the calculator so I can use it as an exact answer. So I'm going to divide by that 4931.51. But again, I'm going to use it in the calculator, so I'm going to type in 62.5 divided by that previous answer. gives me 0.01267 is my rate. Now I really should have specified here how to round to the nearest 100th percent. Does that mean I round that to 0.01? No, because it's not a percent yet. I have to first make it a percent before I round it. And I did that on purpose. I catch a lot of people with that on the tests every year. So I make it a percent first. What's it going to be as a percent? 1.267. Now I round it to the nearest hundredth, which would be here. So that's going to be 1.27%. Any questions? That really ugly thing? Oh, I got to make you work a little bit. Your calculator works a little different. I'll have to talk to you about yours a little bit. Okay. Let's do one more example, then it'll be time for break. How long would it take for $800 to double at 9% ordinary interest? Okay, go ahead and try that one in your notes. What's going to go in for our interest? $800. What's going to go in for our principal? $800. What's going in for our rate? 0.09, and we're looking for the time. Realistically here, we could do some cheating, but I'll go ahead and do this the long way. 800 times 0.09 is going to be 72 times t, and we'll solve for t by dividing by 72. Gives us 11.11 years is our time.
So why did you say double?
Doubled?
Yeah, like for it to double.
Yeah. So I mean it doubled, so it went from 800 to 1600.
Right.
So the interest was $800, the difference.
I use 1600 as the interest.
As the interest? So that would have been tripled.
Okay.
Yep. Okay, let's go ahead and take our break. Let's come back at about 6:29, 6:30, and we'll start over again.